Creating Transparent Acrylic Edges, sponsored by Styles Machine. I'm happy to welcome James Swanson as our presenter. James is a CNC product specialist at Styles Machinery. He's been managing the Styles Edge Polishing program for several years. He's presented at a number of seminars focused on the plastics industry throughout his career. In this webinar, he'll provide an overview of different machining and tooling technologies for edge polishing acrylics. Before I pass it over to James, I'd like to cover a few housekeeping items. First, if you have a question during the presentation, please submit it using the webinar toolbar. James will answer those for you at the end of his presentation, but we don't want you to forget your questions or anything, so feel free to go ahead and type them in. Second, 1 hour after the presentation ends, you will receive a survey. Once you've filled out the survey, there will be a link to a PDF of the presentation slides. And third, you will receive a follow-up email from IAPD that contains a recording of the webinar. The recording will also be available on IAPD's YouTube channel, so you can share that around with people if they weren't able to make the live presentation. With that, I would now like to turn the presentation over to James Swanson.
All right, thank you, Carly. So we're going to give it a second for this presentation to load up here. While that's happening, a little bit of background about Styles Machinery and why we are involved in sponsoring these type of education events. Styles Machinery as an entity has been providing machinery solutions to the woods, plastics, composites, and non-ferrous metals industries since 1965. A little summary of those solutions include CNC machining centers, sawing machines, edge processing, which we'll talk about today, sanding solutions, digital printing, as well as material handling. What we're going to focus on today, and I'm hoping you all see on your screens, is machining solutions for edge polishing acrylic materials. Let's start with, kind of summarizing why does polishing acrylic matter to us as a company and you as an end user of that product. Of course, it's a very aesthetically appealing material when it's processed correctly. It's a value-added or growth avenue for many of our customers. What we find is it crosses over in many industry segments. A couple examples of those segments: exhibit componentry, point of purchase and store fixture manufacturers, interior design, as well as furniture production. The problem that our customers bring to us with producing a high-quality polished acrylic edge is that it's typically a very manual process that they're not very efficient at producing. Some typical steps for manually polishing an acrylic edge: scraping, hand sanding or orbital sanding, and then followed up with either buffing or a secondary process known as flame polishing. Now, it's clear in the industry that these all can be used to produce a high-quality acrylic edge, but what our customers tell us is they're very time-consuming. They're inaccurate because there's a lot of manual processing happen to let's say you've got a 1,000-part run that you want all to be exactly the same. It's difficult to achieve that with a manual application. They're labor-intensive, and in some cases they're very difficult depending on the geometry of the workpiece you're trying to polish. So, of course, the question will come up: what are some of the alternative technologies available in the marketplace? We'll talk about three today. The first being mechanical edge polishing machines. The second being a mechanical edge beveling machine. And the third, using CNC router technology to produce polished edges on what we'll call non-rectilinear or non-square workpieces. All of those three technologies is to create an effective edge polishing from cost-effective machinery and quality tooling in lieu of sheer labor. Let's touch on that first technology being mechanical edge polishing machines. The first category we'll talk about is a system that is a flexible system, meaning its ability, or it employs the ability to process a 90-degree polish on a piece, as well as to produce a bevel on that same workpiece. What we're going to do throughout the next 3 or 4 slides is kind of give you an overview of the technology, but then also follow that up with an interactive video for each technology. In some instances, you're going to notice a little lag in the video coming up on your screen. It's important to note that after the presentation is finished, you will have access to these videos either within the presentation forwarded by IAPD or a secondary link to the machinery or the video on YouTube. So let's pull this first one up. This is a mechanical edge polishing machine for fixed as well as beveled edge processing. Okay, so if we're taking notes, it's important to note on that first technology there, that's a fixed material, meaning we bring the material to the machine and it affixes it in place and then moves the tool across the face of the workpiece to mill and polish the machine. Some of the benefits of that fixed material moving tool approach is we're able to take bigger and thicker workpieces into the machine because we're not manually moving them across the fixed tool. So for example, a heavy piece of acrylic, a 3-inch by 10-foot by 4-foot slab of acrylic you're going to process, that type of work application is better suited to fixed material moving tool production. You'll also note With the processing thickness of these type of solutions, you're able to stack materials up to the maximum part thickness of the machine and get multiple parts out of the machine in a single cycle over some of the moving material fixed tool solutions we'll talk about here next. And then the thing to remember about that, although the video just barely touched on it, flexible machine, 90-degree polishing, as well as the ability to be converted to bevel. The next technology we'll review will be just 90-degree fixed edge polishing. Okay, so kind of contrasting that to the first technology review we reviewed, this slide here, 90-degree fixed polishing, fixed tool moving material, lends itself more to smaller work pieces and obviously a little bit of weight coming into the equation here too, where the machine can physically move the material past a fixed cutter head to produce the desired edge finish. The third version available in the industry of edge processing machines for acrylic is I don't want to call it simple, but a dedicated edge beveling machine. What we'll talk about here is a fixed 45-degree machine, similar to what you saw on the last slide, where the machine will move the work pieces past the tool to provide that 45-degree broken edge on the material. So what you'll notice with that last piece of technology is it's, based upon its simple design and what it's designed to do, it's a benchtop model. Contrasting the first category of machines to the second to the third, you'll notice that they get smaller in size and they also require less girth or build quality to handle a more dedicated process. And the last that we'll talk about is utilizing a CNC router to produce a polished edge on acrylic materials. Some of what we find here is, in terms of value, this system can be utilized to polish non-rectilinear geometries, both horizontal and vertical surfaces within a workpiece. So if you've got a pocket somewhere in a project that you need to produce with a transparent edge as well as a transparent bottom, these type of solutions come into play, as well as producing chamfers and 5-axis processing. So if you look at the photos on the machine or on the bottom of the slide here, if you look at these little left, very tight inside radiuses, areas that are difficult to sand and polish and are not possible to polish on the about previously. The CNC machines with tooling can really come into play here. The workpiece on the right has an A-axis angled hole produced in the workpiece where, utilizing 5-axis technology and the proper tooling, you can actually polish the inside surfaces of that angled hole or that mirrored hole. If you end up considering technologies, we always like to review with our consultancy as to what are some of the more important features of the machines and or it's just to review when you're making these types of decisions. When it comes to polishing machines, history of the machine manufacturer is extremely important. The way we kind of view this market is a bit of a niche market, and when you're dealing with niche markets, suppliers come and go almost yearly. So you want to make sure that the solution you're considering has a good history of success, not only in production in the marketplace, but that the manufacturer supporting it, isn't on his third time in and out of business in the last 6 years. That's really important because, the machine can do what the machine can do, but if there's nobody on the back end to support it, the solution is not going to deliver the year-over-year production that you expect. The design of the machine is also very important, especially when you're dealing with that first category. A moving tool, you're often putting very heavy, thick materials on those machines, and you want to be sure that the machine design is managed to take that weight over the long term, as well as manage vibration and produce a good quality edge for years to come. Material-related parameters is a process in polishing acrylic to gain some momentum, whereas vendors offer machines that are pre-programmed for feed speeds and RPMs for the specific tooling they operate, the different materials that run. For example, a cast acrylic material versus a colored extruded material, or a polypropylene, a polyethylene, a PETG, all require different machine parameters, how fast you turn the tool and how fast you traverse the tool through the workpiece. And machines have some pre-programmed almost library, can really minimize the amount of training that's required on the front end, and also minimize the amount of manual setup required as you change from one material to the next on the machine. The second is to consider on the big polishing machines is, if you look over here to the right, what's your maximum polish depth? We don't have a ton of customers that we see just after 6 or 8 inch slab polishing depth. But the larger the polishing depth means the larger stack height that you can bring into the machine, and you can really increase the output of the machine by stacking materials and producing parts in that manner. And also, is there a tilting spindle available on the machine to bevel? And we've got to really be careful about how we select machines that are geared to polish 90 degrees but can also bevel. And my point here is we want to match the ability of the machine to bevel with the application on your side, which we're going to touch on here in the next slide. So when you deal with edge beveling, it's important to know if considering bevels from the top of the workpiece or if the cutter head swivels and bevels from the underside of the workpiece, because that has an impact on the quality and accuracy of the workpiece coming out of the machine. And it's also important to state to your machine consultant if you're looking to bevel for aesthetic purposes, meaning you just want to break the good, clean look, or if you're beveling for fabrication purposes, for example, producing a 45-degree bevel on a 1-inch workpiece that you're going to get a 90-degree corner. This matters because of differences across acrylic material. If you're dealing with cast material, it's going to be consistent in thickness across that workpiece. If you bevel that from the top and expect to glue that up at a 45-degree angle, your bevel is going to follow the thickness of the material, and your corners aren't going to match up perfectly. If you bevel that from the bottom, you can work your 0 point from the bottom and put together a 90-degree corner or two 45-degree corners that will match perfectly. The weakness of beveling from the bottom is to get that head underneath the table surface of the workpiece. You really don't have much support there. So what you typically see in the industry is a fixed material moving tool edge polisher that bevels from the underside will produce a less quality finish when you're using it for 90-degree polishing because there's less girth in the main beam of the machine. Fixed material moving tool polisher that bevels from the top will follow the inaccuracies of your workpiece. In the event it's a cast acrylic material, if it's an extruded acrylic material, you don't have much issue. But the 90-degree polish on that type of scenario will be much better and will have a longer longevity on the machine because those machines are much more robust in terms of the support beam that carries it. So what you really have to ask yourself in terms of beveling is, what's your focus? Do I want to configure a machine that is really configured for 90-degree polishing that can bevel, or do I need a machine that's going to bevel 90% of the time that can also produce polishing on a 90-degree workpiece? This is an area that's a little bit confusing to some. I don't want to bore everybody with it, but if there is additional questions, we can answer these at the end of the presentation, or my contact information will be on the end of the slide where we can pick this up on a direct conversation. In terms of edge polishing and beveling technologies, the tooling system is as important as the machine itself. What you're going to find is that the equipment is actually manufactured around the tooling system. And what's proving itself out over the last 5 to 10 years, that a machine that has the ability to employ a natural diamond tool is a better finished quality that requires less manual processing after coming off the machine than a system that spins what we'll call a synthetic or a polycrystalline tool. And just the same as you need to make sure that the manufacturer producing the machine has a good track record and is a healthy business, the company's supporting and tooling system is that's across the board. An polisher that doesn't have access to tools when you need them and in the configuration that you need them, isn't going to produce the desired results for your company. You'll notice over here that there are systems on the market for these machines that offer a very high degree of flexibility. You can change little inserts in the cutter head that remains on the machine to different styles of diamond, grinds of diamond, different setups for different types of materials. For example, if you want to use the machine to face mill rather than polish to give yourself a nice machine surface for butt joint glue up, there's different tooling configurations available for that. In so much as you can change over from polishing a 90-degree edge on acrylic to producing a frosted or milled edge on a different plastic material in really about a minute with some of these insert flexible tooling systems. And it's also, you know, the user-friendly and quick change nature of some of the systems that are coming to market are also proving very valuable. All right, so now let's move from the dedicated polishing machines to utilizing a CNC machine to polish what many believe is not possible to polish on a machine. So if we talk about inside radiuses, outside radiuses, bottom vertical polishing, chamfers, etc. And the thing to remember here is that utilizing the diamond tooling on a CNC can save a lot of time. It can allow you to take to take projects that you would typically shy away from because they are so difficult and time-consuming. And in terms of large quantities of the same part, it's a very repeatable process. Focus again, largely tooling related. The particular example we're going to use here in a minute, it is a company that manufactures tooling for and only for processing acrylic materials. That's all they do. No wood, no aluminum, no anything else. And that level of experience and expertise for us as we consult with our customers has been very, very beneficial over the past years. So rough cutters and also the natural diamond tools that we talked about in the previous slide. Again, high degree of flexibility, different configurations, different cutter depths and diamond thicknesses for thin and or thick materials, different angles, horizontal and vertical surface processing. What we're going to do now is pull up a video. This video is roughly about 4 minutes long. I'll probably narrate a little bit as it goes through. But in terms of learning something today that you may not have been exposed to previously, this tooling package here might be something you haven't seen in the past. So what we're watching here is that's a standard O-flute tool roughing out the geometry of the part. now we're going to come back through with natural diamond tooling brazed to shank tools for CNC machines. This next process will polish the vertical surfaces. So in terms of what you're seeing, we're coming through with the diamond and shaving about 0.2 of a millimeter off the workpiece. For those of you that are tooling guys, notice the geometry of the chip on the back of the mat there. Very thin and very straight. Now we're coming back through with a bottom polishing tool to polish the bottom surface of that pocket on the top of the workpiece. Upcoming process is a 45-degree polished chamfer on a radius. All right, I apologize for the terrible music in that video. Now, if you're anything like me, when I was first approached with this technology, we've had experience with the polycrystalline or the synthetic diamond tools for years with acrylics, and you just never seem to get the finished quality that you really expect from a tool that carries that level of price tag. Working with this stuff, it really takes what you would expect from a polycrystalline tool you might be working with now and gets you that extra 30 or 40% in finished quality that you really want. And the goal there is to really minimize the amount of manual labor coming off these difficult, intricate parts off the CNC machine. If this has piqued your interest, we got to at least throw caution out as to what to look for in terms of the types of CNC machines that are robust enough to spin a natural diamond tool in that 24 to 35,000 RPM range. Just to quickly go through a little bit, appropriately designed, quality drive package. We're looking for some rigidity in the router in terms of its router carriage and gantry and or cantilever depending on its vintage. Quality spindle, of course. Automatic tool changer, really a must in terms of looking at what we just did. We took 4 or 5 or 6 diamond tools automatically throughout the machine. There are CNC machines out in the marketplace that offer an automated tool pickup station, not for changing tools during a process, but for quickly taking them in and out of the tool changer without the operator intervening or choosing where those tools go. That can have some value in terms of managing your tooling cost by taking some of the human error out of managing the tool changer. And efficient vacuum system and or the ability of your machine operators to fix your small parts like we did in the video that we just watched. An example of some of this technology in production. There's a company in Las Vegas called Acrylic Tank Manufacturing. They've been manufacturing high-end fish aquariums for many years. A few years ago, they hooked up with Animal Planet, and they have a TV series on, I don't know if it's Animal Planet, called Tanked. And this particular production outfit, operating a CNC router, a beam saw, sliding table saw, all 3 of those solutions geared for acrylic processing, dust collection system for plastics, as well as 2 of the 3 edge polisher technologies we talked about in the very beginning, the larger fixed material moving head polisher, as well as the small desktop 45-degree bevel machine. I did throw this last piece of technology, and it looks like we're doing okay on time. They also have, or will have, a plastic V-grooving machine. So if a portion of your business is miter folding plastic boxes for glue up or heat bending 90-degree edges, where in terms of when you heat bend this part in the bottom corner, you tend to see that little bulge or in some instances a crack where you're forcing that material out of the joint. You can use a V-grooving machine to kind of remove about half of that material and get a nice clean 45-degree bend off your heat element as well. We'll show you a quick video here. Okay, maybe a little bit outside of the edge polishing focus of the presentation here, but I chose to include it. We see that technology in operation a lot in Europe, and not very often in many of our U.S.-based manufacturers here. And I just don't think it's well known that those machines exist in our industry. All right, we'll have a question and answer session at the end here, but I'm just going to kind of take 2 or 3 of the ones that we typically get in these type of education sessions. And the main one is all right, what are we talking about there in terms of tooling life and tooling costs on these edge polishing solutions? In terms, it's a wide open answer. I can't really peg it because it's really dependent on how much material, how thick, and how many linear feet you process on that tool. But we typically see customers replacing tools anywhere from 15 to 60 days, and it's largely dependent upon the finish quality or the specification that you're building materials to. Some guys want very, very little or no manual labor coming off the machine, and in turn to receive that level of quality, you replace your tools quicker. I think we average out about 60 days, and I know of some customers who will run tools up to about 6 months before their customer specification of the product is not met by the machines. In terms of tooling cost, and this will give you just on the edge polishing machines, you have pre-cutters in the machine that take out most of the material, and then the diamond finisher that comes through and puts the finished quality edge on the workpiece. The pre-cutters are about $500, and depending upon the quality of the diamond we're putting in, it should be upwards of $2,500 plus if we're putting a large processing depth diamond C machine. What's important to know about some of these tooling suppliers is that, it's not a $2,500 investment in the tool and another $2,500 when you need to replace it or have it serviced. The last point here is typically the natural diamond tools and or the polycrystallines for that matter are serviceable for about 15 to 30% of what that tool costs new. So by having that service plan put in place with your tool supplier, you can minimize and effectively manage the cost of your tooling in these machines. Another question we often get is, can you glue parts together that have been processed on a diamond edge polishing machine? And the answer is yes. They provide a very square edge for accurate assembly. It eliminates some of the stress caused by other prep methods and reduces the risk of crazing those workpieces as you process them through assembly. Move into a quick summary here. We talked about 3 or 4 different technologies. The first being a flexible edge polishing machine, 90-degree polishing as well as beveling. The second, fixed 90-degree polishing. The third, fixed 45-degree beveling. And the last and most intriguing, natural diamond tools for CNC machines. And the thing to remember there is accurate polishing of non-rectilinear geometries, anything that's not straight. What's in it for you often comes up. James, that's great. There's a lot of technologies in the market. What does it mean when we employ them? How can you help us justify them? What information are the customers in the marketplace that currently have them feeding back to you? And we'll review a short case study here of we'll call it a high volume job, comparing it to how the job was processed manually to begin with, and what the decreased labor and decreased processing time was coming off a mechanical polishing machine. So to kind of give you an idea of what the work pieces were, 4 inches wide by 31 inches long by 1 inch thick cast acrylic workpiece. The 2 long edges were what we were looking to polish. The 2 short edges remained as the customer processed them off their router. Their manual process to produce the desired finish quality on the long edges was 5 minutes in sanding. It was an orbital sanding application through 2 or 3 different grits, 4 minutes per part on the buffer. So we come out with a total time there of about 9 minutes per part. We're noting ABP here, but this is actually, that's just a brand name. Your time coming off the mechanical polisher, 3 of those 1 inch workpieces were stacked together. So 3 edges processed in 1 machine cycle. And that was 2 minutes per side. So a total time of 4 minutes. This time study was done when the tools were about 15 days old. So we were buffing about 1 minute, 30 seconds per part to just, to kind of get some of the tool striations out and get that transparent, flat as glass finish the customer required. And if you compare the 2 together, the mechanical machine versus manual processing exhibited a total time savings of 18.5 minutes per 3-part run, which is about 68%. And in terms of manpower savings, the manual scenario in that shop had 5 people required to process those parts. I think it was about a 2,500 part run. In the sanding and buffing room, those 5 people, so they were, when the mechanical machine came in, 1 person running the machine and 2 people on the buffers, compared to 5 people on the buffers before, which tags out at about 40% labor savings. Comment from the customer while this was happening, on that job, the statement was, we can now make money on the production of those parts noted above, rather than hoping to catch all the breaks and really break even on the job. Some of the points that he made, sometimes those parts will come through and be processed manually, and all those guys are having a great day and they're fast, and the next day, whatever happened, their wife isn't treating them right, and their output is much. When you're dealing with mechanical or machine technology, it's bankable. You know exactly how long that machine's going to take to go from point A to point B, and it's going to take that long every single time. Some of the additional value of having the technology in your shop: less wear and tear on your employees, improved employee morale, improved part accuracy. Kind of tying to that in with another customer comment, our guys disliked the sanding and buffing room. With the implementation of the mechanical edge polishing machine, which virtually eliminated or did eliminate the sanding requirement to process those parts, now the guys like the buffing room. They turn on the radio, crank it up, and whip the parts out. So in terms of what it can mean, the machines can be very powerful over typical manual process. They can bring a high potential for increased profitability to the company bottom line. They can offer a very nice and justifiable return on investment or payback period. They'll save time. They'll improve quality of the outgoing workpieces. They'll provide repeatability in terms of part size as well as time required to process the part. And they'll improve the work environment in the shop. At this point, Carly, let's open it up for questions, and we'll attack them as they come in.
Okay, thank you, James. Yep, as a reminder, if anyone has any questions, you go ahead and just send them in through the toolbar, and we'll get those answered for you. Yep, and we've got James's information here. I know that sometimes it's a lot of information to take in for people, and if they think of a question afterwards, then they can certainly email or give you a call. Let's see, we'll give it just a minute here. All right, and like we mentioned, James mentioned, and I mentioned that ahead of the presentation, you will get a survey here in about an hour. You'll have access to the presentation slides. Within those slides, we'll get you the videos that you saw, and then we'll get you a recording for the, a link to the recording of the presentation as well. Hopefully I'll have that up on YouTube either today or by early next week, and then I'll email everyone out to let them know that that link is available. So before we go, I would like to thank our presenter James again and Stiles Machinery for sponsoring the webinar. We do have, Stiles will be presenting again in November, so be watching the IAPD website for more information about that presentation. And we have another webinar sponsored for next month as well in October, so you can find all of those details on IAPD's website. James, any final words from you?
Nope, just like to thank everybody for their time today, and have a great weekend.
All right, thank you so much. And again, please feel free to reach out to James afterward if you think of any questions or anything. And again, we will have links to the videos and links to the case study and that kind of thing. So thank you, James. Thank you, Stiles. And thank you, everyone, for attending. We hopefully will see you again next month. Bye-bye.